Hi folks, I'm going to do a quick video today on testing in Foundry. First thing I'm going to do is forge init to initialize our Foundry project. And for the test, I'm going to use the default files that are here. So we have a script, we have counter.sol, counter.t.sol, and then we have script. I'm going to get rid of script. And we'll keep counter. We'll actually change the name of it. So rename it. I'm just going to call it ETH wallet. We'll rename our contract to ETH wallet. I'm just going to delete this stuff here. Change this to MIT and save. Rename. It's going to be ETH wallet. And remember, it's .t.sol for tests. Okay, so yeah, that's the convention. We'll change this ETH wallet. Copy that. And I will change this to ETH wallet. And this is just to have an instance in our tests. Okay. So I'm gonna get rid of these to start off with. We will do this. We'll change this to wallet. We're just gonna do ETH wallet. There we go. I'll get rid of this. Okay. So now we have the bare bones of it set up. So we have the outline of our test contract set up and our smart contract with nothing in it. So what I'm going to do is we're going to set up a couple of environment variables. We do a mapping for balances. So we're going to do address user maps to uint 256. I'm going to say collateral. It's not going to be anything major. We're just doing a quick test. Balances we'll call it, and then we'll do uint 256 public, and we will call this number of depositors. Okay, just so we have a couple of variables to check, and then we're going to use a function called deposit. We call it deposit ETH collateral. We're going to use message.sender rather than ERC20s or anything like that. So we do it like this. So we're going to make it payable because we are taking in Ether. So the first thing we're going to do is we're going to require that the amount sent in is, we're going to do require, and we'll do message.value, value even, is greater than 0. So we have to send something, otherwise, please send more than 0. The next thing we'll do is we will update the balances. And we're going to say the balances of message.sender, and we'll do plus equals message.value. And then we'll do number of depositors plus equals 1. That's the outline of our smart contract. So all we're really doing is we're going to pass ETH into this function, a payable function. We're going to check that it's more than 0. Then we're going to update the balances of the balances mapping, index that the sender to whatever they've sent, and then we're going to increment the number of depositors to by 1. Okay, now we switch over to our ETH wallet.t.sol. This is our test, and so the first thing we've done is we've have an instance of our contract here. We set it up. So the setup function is a special function that runs before every test. So it'll set up an instance of our ETH wallet. Okay. Now we're going to need a user to actually use our function and our contract. So we call user public, and we call him Bob, and we'll just say it is make addr, and this is the syntax. And what you can do is you can just put in something like that, and it'll make a wallet based on whatever you put in here, and that's going to be called Bob. Okay, and because Bob is going to be the user, and we're going to be testing, and every function we're going to really need Bob to test, we'll do something. So vm.deal, this is a cheat code. There's cheat codes in Foundry, and for example with deal, what we're saying here is we want to give Bob, and what that does is it says give Bob an amount of ETH. So if we say 10 1 2 3 E18, that's going to give Bob 10,000 ETH. So every time a test is run, it'll run setup, it'll create the new contract, and for that contract Bob will now have 10,000 ETH that he can use to test the contract, or send to the contract to say we're doing the testing. Okay, so I think the first one we do, and this is the syntax again, it's function, and make sure that you have test as the first thing. If you don't have test, if you have something else, it's not going to run with your tests. And we will add one in that's kind of like a helper afterwards in a minute, but we'll do it like this. I'm going to do test deposit. What do we do? Deposit collateral, because that's the name of our function, I think. Deposit ETH collateral. Yeah, we'll just call it that. And we're going to do expect revert, and we say no ether sent. So this is going to be testing our require statement that we set to say that that we set here, where we said that the first thing we're going to do is to test that more than 0 ETH has been sent, otherwise please. So I'm going to copy this error because that's going to be required, because it's going to revert with that error when we send 0 ETH, okay? So switch back over here to the test. Now, so again, one thing we have to do when we're doing this is another cheat code is prank. So that's a cheat code, and what that does, if you do this and you do Bob, the next line that's run will be simulated as if Bob is sending a transaction. Now, what I'm going to do is I'm actually going to use a different syntax because I want to have everything in it. So this is another syntax. You can do start prank, and you can do vm stop prank. And what that'll do is every line in between start prank and stop prank will be run as if it's coming from Bob. Okay. So what we'll do is we'll do vm expect revert, and we're going. And as I said, this is our 1 second. This is what it's going to revert with if we don't have any if we don't send any ETH. And what we're going to do then is we'll do wallet. We'll call the function deposit ETH collateral on our wallet. And what we're going to do is we're going to send in value. We'll just send in 0 ether, and then we just do this. There's no params going with it. So there we go. So what we're saying here is test on our function test deposit collateral expect revert no ether sent. We start the prank as if it's coming from Bob, and we're expecting this revert to happen when we send 0 ETH into the contract. Okay, so just do a quick test on that, and we'll do forge test. There we go. Let's give it a second. And there we go. Our test is passing. Okay, and just to show you, if we send in 1 ETH, this test will fail. So again, we're not testing whether it's successful or not. We're testing that it's reverting, because that's the behavior we're testing. Okay, so if I do this again, let's pull this up a minute. Just gonna do forge test. That one passed because I didn't save it. 1 second. We'll save it, and this time it should fail. There we go. So the call did not revert as expected. Okay, and if we do this, I'll just clear it one more time. Do forge test, and we go dash vv. That should give us, when you do, it'll actually give you the call stack of what's happened. So you can see down here, ETH wallet value. So you can actually look through the call stack the entire way. So you can see that the setup ran first. Then you can see that our test was run here. Started the prank as Bob. Expected this revert. Then we deposited, and as you see, we deposited, and the call did not revert as expected. So you can kind of troubleshoot it using that. Okay. Okay. So next thing we want to do is we want to do a function to test deposit and deposit collateral. But this time we want to check if what do we say? So we're testing this time to say that the user balance updated. So if we successfully send in what do we call it? User balance should update, we'll say. Okay. And it's public. Okay. So once again, we're kind of going to do something similar to this, but we're not going to use the expect revert in this test, because we're not looking for it to revert. We actually want the test, so we don't need the expect revert, but we do want this. And actually, I better change that back to 0, because we want that test to pass. But this one is actually okay at 1 ether, because we want to get by the require here. So we're sending in some ether, and once we get by that, it should update the balance as a message of sender to the message of value, which will be 1 ETH in our case. Okay. So what we're doing here is we're going to do this, but then that's not what we're testing. So this is just essentially to get 1 ether into the contract. But then what we want to do is we want to call the balances. So we call uint and we'll say Bob balance. Oh, spell that correctly, balance. And the Bob balance is going to be equal to wallet dot balances, and we just look for the balance of Bob. And then what we're going to do is, again, and this is how we do assert equals. So and what we do is we have 2 statements in here, or 2 variables in here. So Bob balance, and we're going to say that we expect Bob's balance to be 1 E18, which is 1 ETH. Okay. In fact, what I'll do is I'll copy this, I'll change this, and we'll put it up here at the top. We'll just call it yeah. we go uint 256 public. Let me just say 1 ETH equals that. There we go. Yeah. So what we're saying here really is we expect Bob's balance in the contract to be equal 1 ETH. That's what we're saying there. And if we run that, the test should pass. So clear. So another thing to do here is rather than testing all of them every time, because if you have, say you had 100 tests, you're just gonna be seeing them all in one thing. So you can actually do forge test dash dash match test and just paste it in like that, and it'll give you the specific test. And this is handier for stuff like if you wanted to do that and then you wanted to do this to get your call stack. So there you go. So you can see that. And deposit e collateral 1, and then it's the balance that comes back from the call is 1. So that's how it's passing. Okay. That's that one there. So for our next one, we will test again. It's going to be deposit collateral. And we're going to expect, no, not we're going to expect, we're going to check that the number of, what we do, user balance should update. So we'll say number of depositors should update. Public. And again, we're going to do this, and we're going to have to do this because we want to make sure, because again, these tests, in this case, we're running each test individually, and setup is running before each test. So in this one, if we don't run the start prank, stop prank, Bob won't actually have deposited 1 ETH into the contract, okay? So we're going to do this, but rather than doing that, because you might, at the start, you're going to probably test if your functions are bigger, and of course they're going to be bigger than this. This is just for messing around with, okay? So you're probably going to have a lot more in there, and you're going to want to run this. You might want to run this every single time that you're testing the test deposit collateral function, but you don't want to run it every time every single test is run, okay? So what we're going to do is we will just create another one down here, and we're going to call it function. In fact, we'll call it, I'm not sure of what they're actually called by Foundry. We'll call them helpers until I find out what they're called, and I'm sure it's in the docs. And we're just going to call it function, and we'll say, what we call it, underscore, I think is the convention, deposit, that's deposit. What do we say? 1 ETH as Bob, and public. Oh, do that. I'm going to paste this in here, and now what we can do is we can take this function here, and instead of running this every time on different lines, we just go like that. There we go. Then we do it here, and now it just makes it a bit easier. It's similar to having your kind of similar to having just an internal function essentially that the test call, but it's not run because it doesn't have a test at the start. It's kind of like the regex doesn't catch it and it doesn't run it. So if we run forward test now, it's not going to run this. It's only going to run stuff that starts with test. Okay. So that's one, and what we're trying to do here is I will just pop it down the next line. uint 256. I'm seeing number of depositors equals in its wallet, and it is number of depositors. There we go. Just call that. And again, we do assert equals number of depositors, and because only one, again, this test runs independently of this one. So setup is run on its own again, and Bob is only just put in 1 ether, so he's the only person that's done this in the contract. So again, that one, and we'll just test it individually, but that should pass there. Number of depositors after Bob has put in 1 ETH should just be 1. So we'll just do a quick test. We'll do forge test dash dash match test, and there we go. So that's it. So our test should be passed. Just do forge test. We'll see there now. There you go. So all 3 tests are passing in that case. If we do forge coverage, I mean, this is a very, very simple contract. There's probably not a huge amount of test in it. Yeah, so again, look, everything is being tested in this contract. You know, as your contracts go, you'll see that, if you hit each function, you might say that the functions, even if you hit one statement in the function, I think you could say that you have all your, say if you have 20 functions and you test a require statement, they'll say they're at 100%, but you really want to get all your lines covered, your statements, and eventually your branches, where your logic kind of splits off within each function. But that's it's only an introduction, I should say, to Foundry testing. It's very, very good. It's great for, you know, I think in previous videos when we were testing our minimal DeFi contracts, what we did is we were going into what do you call it? Cast, Foundry Cast, and calling the contract an anvil, and that's how, you know. But this is the real way to do it, to test out your contracts, and it's much easier than kind of deploying it to anvil and testing and calling continuously. But yeah, so this is just an introduction to some of the cheat codes, such as start prank, stop prank, expect revert, deal, make address, and stuff like that, and they are very handy.